If you have an automobile, a motorcycle, lawn equipment, boat, ATV, a battery charger is a good tool to have. I just needed to replace an expensive battery, which I probably could have avoided if I had it connected to a proper float charger while it was in storage. I've been thinking about getting a good maintenance charger. So let's talk about your choices for battery chargers. I'll provide links in the description below to the products that we discuss. Okay, I have a few different chargers that I use for different situations. Let's review the battery chargers that I use. First up, the STANLEY BC25BS Smart 12-volt battery charger. This is an example of a smart battery charger and the kind of battery charger that I would use in most situations where I have a weak battery that I want to quickly recharge. An alternative that I find interesting is the NOCO Genius series chargers, which might be an even better choice. The BC25 has some nice features. The most important may be that it monitors the battery condition and it charges it appropriately and will not overcharge and damage batteries. Intelligent chargers use smart charging methods such as incorporating constant current or constant voltage programmed to run in cycles. This can optimize your charging rate while being gentle to the battery. These units use switching power supplies, so they are lighter and more efficient than the old-style units that used big transformers and are probably less expensive to manufacture. These chargers apply a strong charge for batteries that need it, and then it backs off and acts like a gentle trickle or float charger to properly maintain the battery once it has been charged. This BC25 unit also has a voltmeter, which I find to be a very nice feature, so I can check the status of the battery before I begin charging. A fully charged battery should be 12.6 to 12.7 volts. At 12.0 volts, that would indicate that the battery is 50% discharged. And at 11.5 volts, the battery would need a full recharge. If the battery is below about 11 volts, it's deeply discharged, and that could impact the battery's lifespan. A nice safety feature that sometimes can get in your way is that this charger does not begin charging until it senses that a battery is attached. So that means that the charging clamps will not arc if they are accidentally touched together or spark when connected to the battery. Sparks on the top of the battery could be potentially hazardous since batteries emit a little bit of flammable hydrogen gas, especially while charging. This unit will sense if it is connected properly to the battery or if you have the clamps accidentally reversed. The downside is that if the battery is very weak, below about 8 volts, this charger will not activate and charge the battery. Of course, if the battery is that weak, you may not be able to recover that battery in any case. Some smart chargers do allow you to override this feature, so you can attempt to charge really dead batteries. Another feature that this charger has is a battery recovery mode, where it blasts the battery with high-frequency pulses that are intended to break up and dissolve any sulfite coating that has formed in the battery plates that would degrade battery performance. This charger's recovery mode can take days. Sometimes the feature works and it increases the capacity of the battery, and sometimes the battery is just too far gone for it to be effective. This particular charger is offered in a 15 amp or 25 amp version. Personally, I would suggest the 25 amp version because if you have a weak, larger battery, it will be able to charge it more rapidly. A nearly fully discharged battery will probably require a full overnight charge at 10 or 15 amps to completely recharge, whereas at 25 amps you can probably do the same job in about an afternoon. Really high current chargers can charge even faster, but you could risk damaging the battery with excessive charging current. If the battery just needs a top-off charge, it will only draw as much current as the battery requires, and in that case, a large battery charger isn't going to charge it any faster than a smaller unit. 25 amps is capable of a pretty strong charge, but not enough to really cook and damage most car-sized batteries. So I would suggest that a 20 to 40 amp charger is a good sized unit to go for if you want to be able to rapidly recharge full-sized car batteries. Some of the issues that I've experienced with this particular unit. My particular unit has a noisy fan. The fan is a small computer-style fan. This charger also, like I mentioned, won't activate unless it senses battery voltage. So if your battery is very weak, less than about 8 volts, this charger will not start. And because of that, sometimes I have to use a different charger to get the initial charge going and get the battery voltage up a little bit. And then after a little while, I can put this charger, the smart charger, back on it to finish the job. Of course, if the battery is that far discharged, it's uncertain if the battery can be recovered in any case, or if it will recover and regain usable capacity. One odd behavior of this unit is sometimes it will stop charging, and then after a little while go back into a charging mode for a while, and it will do this for a few cycles. I don't know if it does this because the unit heats up and has to cool down, or if it's just part of its programmed charging cycle. I'm not sure. But in any case, it's not really an issue because the end result is a charged battery. Some neglected batteries that are in very poor condition will measure a full 12 volts, but they're not really capable of delivering real power. And sometimes this charger will get fooled, and it will sense that voltage and assume that the battery is fully charged, and it will stop. Whereas I've had some other chargers that realize that the battery really does need more charge, and they will continue to push the needed energy into the battery. The bottom line, overall, for quickly charging up good but weak batteries, this unit or an intelligent charger like the BC25 or the NOCO Genius is a great choice. I recommend the BC25, but another example of an intelligent modern battery charger would be the NOCO Genius series. These units are microprocessor-controlled, multi-stage chargers, which may be even smarter about properly charging batteries than the BC25. This kind of charger is the choice that I would suggest most people pursue for general-purpose battery maintenance. And if you don't already have any other battery chargers, this is the type that I would suggest most people get. Next up, a jump starter portable lithium battery booster pack. With the advent of new lithium battery chemistry, we now have fairly small portable battery packs that have enough energy to be used as automobile jump starters. These are convenient because it doesn't require another power source. So you can be out in the field or rescue a car on the side of the road with a jump starting battery pack. Not all of these battery packs are equal, however, and many of them cannot really provide enough energy to start a large cold engine with a very weak battery. So I would pursue the largest jump starter battery pack that you can afford. Using a jump starter battery pack like this may get your engine started, and at that point the car's battery charging system should begin charging the vehicle's weak battery. Automotive charging systems are not really designed to charge up dead batteries. They're designed to top off and maintain batteries. Over time, they eventually will fully charge a battery. It takes hours, however, to completely charge an automotive battery, so it will take an awful lot of driving to fully recover that vehicle's battery. I would suggest these devices be used for emergency rescue situation, and then at the next opportunity, I would put a proper battery charger on that vehicle's battery and finish the charging with an overnight charge. And of course, after you use the jump starter battery pack, you will also need to recharge the battery pack, and that will probably take hours to do so as well. I think these jump starter battery packs are a good rescue tool, but I don't think that they replace the need for a standard battery charger. Hey, please don't forget to like and subscribe if you haven't already, and hit the notification bell to be notified of new videos. The next type of charger is a maintenance or float charger, such as the Battery Tender Plus. I have a couple of these battery tender devices, and they are low output, slow chargers and maintainers. I use these on equipment like the motorcycle, the lawn tractor, or other things that sit around for a long period of time without being used. They maintain the batteries in good condition while in storage and can be used to fully charge batteries if you have the time. These Battery Tender Plus smart chargers have the ability to sense the battery condition and are used to slowly charge up and then properly maintain a fully charged battery. Using a gentle charge and proper maintenance float charge is probably the way to get the most lifespan from your batteries. If you have a significantly discharged battery, a trickle charger like this may take days to recover that battery to fully charged condition. Slow charging the battery is probably the most gentle and best way to charge batteries when you have the time. I have confidence that the Battery Tender Plus chargers get the batteries completely charged up, and they do not overcharge or damage batteries if left connected for an extended period of time. I think some of these low output chargers are a bit expensive for what they are. However, if you consider the price of replacing a battery because it's been neglected versus the price of the trickle charger, it begins to look like good value. These trickle chargers are usually rated for 1 or 2 amps of charging current. Of course, many general-purpose chargers like the intelligent chargers that I mentioned previously also have a float charge mode where they will maintain the charged battery. So if you have a standard intelligent battery charger, a trickle charger like the Battery Tender may be redundant. When considering the price of some of these smart low-output maintenance chargers, a higher output general-purpose intelligent charger that can do trickle float maintenance charging may be a better value. You might want to consider having a maintenance charger for each piece of equipment that sits in storage, like your motorcycle, boat, lawn equipment, ATVs, and so forth. And then the final type of charger is the CRAFTSMAN 175 amp manual charger and jump starter. This is an example of a manual battery charger. I don't own this exact model, but I have a similar kind of unit. These were the kind of chargers that were popular a few decades back, and they do not have sophisticated battery monitoring and charge programs. They just push out power. It's your responsibility to use that power wisely. The good thing about these chargers is that they can sometimes recover very dead batteries, and the larger units can quickly charge depleted batteries. The downside is that some of these chargers will push out energy forever, even into a fully charged up battery, and you can damage the battery by overcharging if you leave it connected long enough. They also don't sense if you have the connections in the proper polarity, so you can make sparks with accidental short circuit connections, or you can drive the battery backwards with current. So you have to be careful. I usually connect the charger to the battery and then I turn it on to prevent any arcing. You can tell if your charger is a manual charger with a voltmeter or by putting it into a low output setting and then quickly striking the 2 battery clamps together. If it's a manual charger, you will see voltage with no load on the clamps or a small spark when you quickly touch the clamps together. I don't advise doing that spark test with a charger on a high output current setting like 50 plus amps, because then you'll be doing arc welding and you could arc burn the clamps, possibly damage the charger, and maybe create some mayhem. Now, some of these chargers are automatic, but not really intelligent. So they do sense the battery voltage, and once the charger reaches a predetermined set point in voltage, it decides that the battery is charged, and then it will not continue to pound energy into the battery. The auto shut-off when charged feature is nice to have. If you push energy into a battery nonstop, even after the battery has been fully charged, you're going to boil off the water inside of the cells, and eventually that will damage the battery. Very high output chargers, over 50 amps, could also damage the battery by overheating the internals of the battery if you leave them on long enough. I have a 200 amp charger, which I think is a good tool for recovering and waking up neglected batteries, or for having enough power to jumpstart a cold vehicle with a weak battery, or to very quickly push enough charge into the battery to get equipment up and running. Sometimes if I have a neglected battery that does not want to take a charge with the intelligent charger, I'll put the high power charger on it at a high output level for a little while so it can force enough energy into the battery to help recover its chemistry, and then sometimes that will allow the battery to start accepting a charge. A few things to know about batteries in general. The thing that most often kills batteries is allowing them to sit around for a long time discharged. If you keep your batteries charged up, they can offer you years of service. But when discharged, they form a coating of non-conductive sulfate on their internal plates. And when charged back up again, that sulfate is returned back into the electrolyte. But if the battery is discharged for a long period of time, that sulfate that forms on the plates can become a hard and difficult to break down coating, making it difficult or impossible to recover the battery capacity. Overcharging the battery with a manual charger can evaporate much of the water in the battery cells, and after that happens, sulfation can occur and the battery becomes seriously damaged. The other thing that hurts lead-acid batteries is deeply discharging them. Many automotive-style batteries will not survive being deeply discharged more than a few times. They're designed to start a vehicle and then be quickly recharged. A typical vehicle start does not deeply discharge the battery. There are, of course, some batteries intended for use such as boat trolling motors or backup power systems that are designed to be more tolerant of deeper discharge. But in general, lead-acid type batteries do not handle deep discharge operations very well. Discharging a battery to below about 50% capacity, that's below about 11.5 volts, will greatly reduce the service life. If you really need a battery that can handle deep discharge, lithium is much better, but they require a different charging system and they're more expensive. Lithium batteries have many advantages, such as they're lightweight and they have higher power densities, but they can create, on rare occasions, spectacular fires if overcharged or if there's a battery failure. When charging a wet cell lead-acid style battery, it's a good idea to make sure that all the cells have the proper amount of water in them. With standard lead-acid batteries, the battery acid that is mixed in with the water will not evaporate, but the water can, especially if the battery is overcharged. So sometimes you may need to top off the water. Rarely should it be necessary to add fresh sulfuric battery acid. Some standard batteries have caps on the cells so you can check the electrolyte level. With some maintenance-free style, wet cell batteries, you can pry the top cover open and still check the water level within the cells. Without liquid inside the battery, the chemistry just doesn't work. You should be using very clean water, such as distilled water or reverse osmosis filtered water in your batteries. Impurities in the water will not be helpful to your battery chemistry. With AGM batteries, also known as absorbed glass mat, the electrolyte solution is similar, but it's absorbed into a fiberglass mat. Generally, you cannot add water to AGM batteries. AGM batteries have several advantages, including a faster charging rate than the flooded type batteries. They're lighter than conventional lead-acid batteries, and they have good resistance to low temperatures and vibrations, and they're spill-proof. Gel batteries use similar lead-acid chemistry, but the electrolyte is in a gel form. You cannot add water to a gel battery. These batteries are maintenance-free and spill-proof. Compared to a wet battery, the gel batteries are a bit more tolerant of deep discharge. They hold charge better in long-term storage, but they often do not deliver quite as much cold cranking current. Try to avoid handling batteries with your bare hands and avoid contact with your clothing. When pouring acid electrolyte, eye protection is a good idea. Remember that the battery may have small amounts of battery acid on its case, which could lead to irritating skin and damaging clothing. You'll see the clothing damage hours later. It's a good idea to keep your batteries clean. Dirt and grime on the surface of the battery can be slightly conductive and actually provide an electrical path that will slowly drain the battery of its charge. Sometimes we suspect our batteries are in poor condition when the real problem is just corroded or poor electrical connections. A corroded battery terminal with a small amount of resistance can dramatically reduce the amount of peak current your battery is able to deliver. If in doubt, remove the cables from the battery and clean the terminals and battery posts well with a wire brush. Auto parts stores have purpose-made wire brush terminal cleaner tools that are inexpensive and work well. Also, of course, battery cables or terminals that are in poor condition can be a cause of resistance, and sometimes these just need to be replaced. I hope you found this quick overview of batteries and battery chargers to be interesting and informative. Hey, if this video offered you value, please consider hitting like and subscribing to the channel if you haven't already. Hit the notification bell to be reminded when new videos drop. If you're interested in any of the products that I've mentioned, please click the links below this video. There's no additional cost to you, and it helps support this channel if you purchase using any of those links. Thanks for your support. It helps me create content, and I look forward to seeing you in the next upcoming video.